Today we're talking some more about parallel and perpendicular lines. So our first theorem says theorem 3.8. Ooh, sorry, that's cut off a little bit. Hopefully you can read it. If two lines are parallel to the same line, then they are parallel to each other. So in other words, if A is parallel to B and C is parallel to B, then A is parallel to C, kind of like our transitive property. Whoops, sorry. So if A, get a better, let's see, we'll try that. There we go. So if A is parallel to B as a given, and C is parallel to B as a given, then we can say that A is parallel to C. So it's a pretty straightforward, no problems there. All right. Theorem 3.9. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. In other words, if M is perpendicular to T and N is perpendicular to T, then M is parallel to N. And we can say this because if we have these two lines, M and N, and they are both perpendicular to T, then these are both right angles. And by our theorem, if corresponding angles are congruent, then the two lines are parallel. So that was from our last section. Okay, so let's look at an application of this. A carpenter plans to install molding on the sides and the top of a doorway. The carpenter cuts the ends off the top piece and one end of each of the side pieces at 45-degree angles. Oops, I've lost it. There we go. So in other words, we've got a top piece of molding and he cuts those at 45 degrees. And then we have two side pieces of molding and they are both cut at 45 degrees. So the question is, are these two sides, A and B, parallel? Okay, so all we have to do is look at this and say that yes, since angles 1 and 2, if we put them up here, when we put this all together, since these are each 45, that's 45 and that's 45, therefore this is 90 degrees. And by our last theorem, if both of these sides, A and B, are perpendicular to side C, then A is parallel to B. That's the one we just proved a minute ago. Okay? Perpendicular transversal theorem. This one says, in a plane, if a line is perpendicular to one of two parallel lines, then it's also perpendicular to the other. Algebraically, if N is perpendicular to L and L is parallel to M, then N is parallel to M. And again, this is kind of the reverse of the one that we just talked about. So these are all pretty obvious relationships. So it's just a matter of remembering to use them when we have theorems, and we'll talk more about that in class. Okay, so in a plane, if C is perpendicular to B and B is perpendicular to D, that should have been a small c, sorry. But anyway, if C is perpendicular to B, B is perpendicular to D, and D is perpendicular to A, prove that C is perpendicular to A. So I'm going to draw a picture. You write all that down. We're going to call this D. We're going to call this A. We're going to call this B. And we're going to call this C. And you'll see why I'm only drawing it part way. So C is perpendicular to B. B is perpendicular to D. D is perpendicular to A. I want to prove that C is also perpendicular to A. So C is parallel to D because two lines perpendicular to the same line are parallel. So C is parallel to D because two lines that are perpendicular, they are both perpendicular to B, they are parallel. D is perpendicular to A, that's a given, and C therefore is perpendicular to A because a line perpendicular to one of two parallel lines is perpendicular to the other. So we have C perpendicular to A because C is perpendicular to B. D is parallel to A, therefore C must be perpendicular to A. I know it's a lot of confusion. We'll go over these a little bit more slowly together in class, but write them down, go back and look again, and make sure that you understand what we've done so far.